So we're going to try a harder redox problem now. So here we've got a longer equation. We want to find out what's being oxidized, what's being reduced, using oxidation numbers. So the species we have here are Mn, O, H, Fe. So we'll start with H. So H, we've got 8H+. The oxidation number of H in this species is +1. Don't get confused with the 8 there. That doesn't matter. The charge is +1, and therefore the oxidation number is going to be +1. Let's go to hydrogen over here. Now hydrogen is in this species, we've got water. So we've got -2 for oxygen, which is always the case, except in peroxides. And we've got +1 for our hydrogen here. And that would work out for water. We'll move over here. I'm not sure why I'm doing these in this specific order. We've got +3 for this ion here. We've got +2 for this Mn ion, +2 for this Fe. And we've got, this one's probably the hardest one. We've got a -2 for oxygen. Now, the sum of oxidation numbers has to equal the charge on this ion, which is going to be -1. Okay. Now, we've got 4 oxygens, so -2 times 4 is -8. So we're saying x take 8 equals -1. So you would plus both sides by 8 in order to remove that. So this is going to be +7 for this Mn ion. So we've got a whole bunch of things there. So obviously the Mn is something that's being changed. So Mn is going from +7 to +2. So that's a decrease in oxidation number, which is reduction. Okay. And we also have another species changing. It's going to be the Fe. So Fe goes from 2 to 3. Okay. So going from 2 to 3 is an increase in oxidation number. So that's oxidation. Okay, so that's our redox reaction occurring there. The hydrogen stays the same in terms of oxidation number. Yes, it's becoming something different. It's forming a new species, but there's no electron transfer. So the whole thing is a redox equation, but that particular species is not really involving any transfer of electrons. Okay, so those are the species that we have here. Here we've got some, I'll just move my head here. We've got some common redox pairs. So here we've got oxidizing agents. Remember, oxidizing agents themselves are reduced, okay, and they cause other species to be oxidized. So O2 is reduced to an oxygen ion, okay, or a hydroxide. We've got ClO minus, okay, so that's the hypochlorite ion that's used in bleaches, and that is going to be reduced to a chlorine ion. Hydrogen peroxide, again, a very common bleach, or it's used at the hairdressers when you're getting streaks and whatnot, and that gets reduced to water. So we've got a whole bunch of pretty common ones here that you will become familiar with as we go through this topic. This one here is called the dichromate ion, and chromium ions here. You may remember using acidified dichromate in order to test for alcohols and whether they're primary, secondary, or tertiary. And that's orange in color. It gets reduced to chromium ions, which are green. Here we've got a whole bunch of reducing agents, which are themselves oxidized. Okay, so we've got, usually it's the opposite of the other one, to be perfectly honest, but we've got a whole bunch there. Okay, so move my head again. So the final practice, sorry this is a bit blurry, we've got a big question here. It doesn't look very big, but balance the following redox equations by separating them into 2 half equations, balancing each, and then combining the pair into a balanced complete redox reaction. So first of all, we want the pairs. So the pairs are H2O2 and H2O, and PbS and PbSO4. So those are the species that are the most similar to each other. They're just getting changed slightly. Okay. Now what we need to do here is we need to complete redox half equations. Okay, so basically we're saying, all right, H2O2 is becoming H2O. We need to balance that half equation. Okay, so the half equation is balanced by using the acronym COHES. Okay, so you can write that down the side. The K stands for balancing the key elements. key elements are everything except oxygen and hydrogen. Now there are no key elements here because it's only oxygen and hydrogen, so that step is done. The next step is balancing the oxygens. Now you balance the oxygens by adding water. So here, oxygens 2 and 1. So I need more oxygen on the right hand side, on the product side of the equation. So let's do that, H2O2, and I'll just put a 2 in front of the H2O. Okay, so now I've got 2 water molecules. Next is H, you balance, so for cohes, H is balancing hydrogens, and you balance hydrogens using H+, okay? So this is in acidic conditions. H2, and we've got 2 H2, so we need 2 hydrogens on this side. So I'm going to go H2O2 plus 2H plus, 2 protons goes to 2H2O. I don't know how to do that. Okay, E is balancing electrons. So the side that's more positive, you add the electrons to that side because electrons are negative. So here we've got 2H plus, that's the only charged species we have. So we need to add 2 electrons to counteract that H plus. So we'll just write again, H2O2 plus 2H plus 2 electrons. Okay, so electrons is just an E with a little dash there, goes to 2H2O. Okay. Now the last part for a half equation is adding states. So H2O2, now it says in the question what the states are, it's got aqueous, so we'll just put a little AQ there. Okay, ions are aqueous as well. This is getting really bad with my writing here. Electrons have no state, and water, it's got here L. So we'll put that there for liquid. Okay, so that's that one done, as sloppy as it is. The next one is PBS. Okay. So lead sulfide going to lead sulfate. Oh, I've run out of room here. Okay. Okay, so we've got PBS going to PbSO4. So again, we're going to do our cohes. So the K stands for key elements. We're balancing the key elements, everything except oxygen and hydrogen. Now again, the PBs and the S's are balanced. Okay, so I'm not going to do anything on that step. If they weren't balanced, I would be just adding coefficients just like you balance a normal equation. O is the oxygens, so the oxygens aren't balanced, and we balance the oxygens by adding water. So we're going to add 4H2O to the reactant side, goes to PbSO4, sorry, ran out of space there. Okay, so next is H. We balance hydrogens by adding H+. So we had 4 times 2, 8 hydrogens, so we've got to add 8 hydrogens on the product side. So we'll go a bit smaller this time, PbS plus 4H2O, okay, goes to PbSO4 plus, and we're going 8H plus. E is balancing electrons, so which side is more positive? That's going to be the side with all the H pluses. How much more positive is it? We've obviously got 8H plus and no other species that's actually charged, so we're just going to add 8 electrons on that side. So I'm not going to write everything out again. I mean, you don't need to, really. It's just, you know, giving yourself a little bit more work to do. So I'm just going to kind of add that there. So it's sloppy, but everything's on the right hand side, so it's all good. Last thing, states. So I'm going to add the states. It says solid in the question, so I'll just put solid here. H2O is liquid. PbSO4 is a solid. 8H plus is aqueous. Okay, and then electrons have no state there. So that's those are my half equations done. The next thing is to combine them to a full equation. So what you have to do now is look at the last 2 half equations that you've got. You need to balance them out so the electrons are even. So here we've got 8 electrons, and here we've got 2 electrons. So that's not even. So what I can do is times this equation by 4. Okay, 2 times 4 is 8, obviously. So all I'm doing is going to be adding coefficient of 4 to all of these species. Okay, so I had a 2 there, so you know, 2 times 4 is 8. and here 8 and 8. Okay, and then we write our full equation. So maybe we'll go a different color here, and we add all the reactants and all the products together. So we've got 4H2O2 plus, now we've got 8H plus and we've got 8H plus. They cancel out. So that's on the product side, that's on the reactant side, gone. The electrons will always cancel out because that's the point of kind of multiplying that by 4 in the first place. So they're gone. Now here we've got 4H2O and we've got 8H2O. So I could get rid of all 4 of those waters and cancel out 4 of these waters to go back and have 4 here. Okay, so here I've got just the H2O2s, nothing else. Here I've got PBS, goes to. We've got 4H2O and PbSO4. Okay, so what have I done here? I've essentially balanced this full equation. So here, things weren't balanced. Okay, so we've broken them down, made 2 half equations, balanced the electrons, and built it back up into a full balanced redox equation. So thank you for watching the video. Your turn. Before next lesson, I'd like you to please try to follow my instructions from the last question and see if you can break down this into 2 half equations, balance those half equations, and then combine them into a full redox equation. Thanks for watching, and I'll see you in class.